Hi! This tutorial will show you in a few minutes how to control LEGO Mindstorm robots using Urbi. We will use the tribot model, which is the default model that Urbi loads from the tribot.ini file. Feel free to edit this file to adapt it for your particular robot configuration. This is the Urbi console, and this is the tribot robot that we're going to control. First, let's connect to the robot and make it move. You have two wheels, named wheel R and wheel L, which are aliases for the speed. So let's assign a speed of 50 to the left wheel first. This is done like that. The robot will start to turn around on the right. The right wheel does not move. So let's make it move in the opposite direction. As you guess, it's easy. Wheel R equals minus 50. And the robot starts to turn on itself. Now, how to stop it? Well, we just have to set both wheels speed to 0, which is done with the wheels group that can be used to assign both wheels at the same time. How can we move straight? Well, we just assign both wheels with the same speed. Let's also wait for 1 second and then stop by assigning 0 to the wheels again. Very simple. You can imagine now how easily you can start to move and do curved trajectories by having different speeds on the two wheels. If you've seen the model tutorial, you know that you can do more, like for example controlling the acceleration by specifying a time to reach a given value. Like here, 3 seconds to reach the value 50, and then again 3 seconds to go back to 0. That's cool. Now, you can do more than motor control with the tribot. You can also access sensors, like for example, the sonar. To get the value of the sonar, just evaluate it in the console. Here it says 255, so there is nothing in front of it. The nice thing about Urbi is that it's easy to do reactive programming with it. If you want to do something when a certain event or condition occur, you can use the @ command, which is a bit like if, but it remains active in the background, ready to trigger. Here, for example, at the sonar distance measure is less than 50 centimeters, then I stop the robot by putting the wheel speed to 0. Now let's make it move forward, and we will put an obstacle in the way to see if it works. As you can see, it reacts in real time. Let's use stop and clean the previous @ command that is still running in the background. As you know, stop no tag will stop any command that is not tagged. Let's use the tag now, and let's make another @ which triggers when the bumper is pressed and then sets the speed to minus 50 to move backward. Here, bumper is one of the many sensors that you can read. See the complete manual for a list. To test this new @ let's move forward towards a wall. Bumper contact, and then backward. Of course, you can run as many @ in parallel as you want. Let's stop the previous one. You might also set the speed back to 0. Now we will use another object called beeper to make a sound. The way it works is to call the play method of the beeper object with a pitch and a time in parameters. Here you can hear a sound in your Mindstorm. Now I'm going to show you another event control command, which is whenever. Whenever syntax resembles the one of @, but unlike @, it does not just trigger once when the condition is met, but it triggers again and again as long as the condition is met. A bit like while. Let's try it. I put a tag. Whenever the sonar value is less than 100, then I echo its value in the console. In normal situation, when no obstacle is in front of the sonar, its value is 255. But when I put my hand in front of it, the value goes below 100, and the whenever is triggered as long as it is so. Okay, let's stop this whenever command. Remember, it's always there in the background otherwise. Now, we are going to speak about parallelism and do some real cool things. I'm going to use oscillation commands, remember from the motor tutorial, and combine them in parallel with the ampersand command separator. Here I start with the right wheel and I make it oscillate with a period of 3 seconds and an amplitude of 50. And I use an ampersand which means that the two commands should start at the same time and run in parallel, to oscillate also the left wheel with a different period and amplitude, which is going to make interesting patterns. I also add a beep. Just I could add anything else I want, including a set of commands between brackets, for example. The last step is to put a comma at the end, since the two oscillation commands never terminate, and we have to put all this in the background. You see the result here, which is a seemingly random walk of the robot with this simple 2 lines command in Urbi. There was also a beep at the beginning of the movement as expected. Okay, let's stop it now, stop no tag, and then put the speed to 0. Finally, now we are going to learn a quite useful notion, which is function definition. It's common to want to pack a set of action you do often in one single command. For that, you can define a function. Let's take an example. Here we define a global.forward function that moves forward with a given speed during a given time. After the function definition, we open a bracket and start to put the code. Here we set the speed, wait for the time given in the timer parameter, and then we stop by putting the wheel's speed to 0. That's it. Now let's try this function. From now on you can use it anywhere in your program. We simply call it with a set of parameters, like move 3 seconds with a speed of 100. Very simple. So here it is. We've seen many things. Of course, there's much more in Urbi, as you can see in the online tutorial. One last thing. You obviously want to store your programs in a file to reuse them later. Just store the program in the same data directory where the tribot.ini file is and use the load command to retrieve it. As a conclusion, we load the demo program. This program is included in the Urbi package, and it moves the robot within the small paper arena given by LEGO, bumping against the black line on the ground. It uses the light object, which is the LEGO sensor used to detect light. Thank you for listening to this tutorial. I hope it stimulates your imagination about all you can do with Urbi and LEGO. The next step is to try it, of course, and to check the more detailed documentation on urbiforge.com, where you can also upload and download scripts with Urbi LEGO community or exchange ideas on the forum. See you soon. Enjoy using Urbi.